Section 3.8, molar mass. Let's rock. Molar masses of atoms. The atomic mass of each element is the average mass of one atom expressed in atomic mass units, or U. There are n sub A atomic mass units in a gram. Okay, so one unit, one atomic mass unit is equal to 1 gram divided by 6.022 times 10 to the 23rd unit, which is equal to 1.661 times 10 to the minus 24th grams. So the mass of 1 mole of atoms then is the atomic mass expressed in grams. So whatever number you see on the periodic table, you can look at that as atomic mass units or the mass of 1 mole of that atom, or sorry, 1 mole of atoms of that substance in grams. Okay. Now, molar mass is a conversion factor. So that number that you see on the periodic table, think about that as a great conversion factor that you can use to bridge the gap between moles and subatomic particles, any number of different things. So what we can do is we can say the atomic mass of carbon is 12.011 U, and the molar mass, so atomic mass and molar mass are different, but the molar mass of carbon is 12.011 grams per mole. Okay, so moles of atoms, our conversion factor right here, molar mass of atoms to mass of atoms. So how many moles of aluminum are present in an empty soda can with a mass of 13.9 grams? Okay, so what this tells us is we've got a mass of 13.9 grams of Al. Now what we want to do is we want to use the information from the periodic table, which I've got in a web browser here. I've got the molar mass for aluminum pulled up, and it is 26.982 grams. So 26.982 grams of aluminum is equal to 1 mole of aluminum atoms. Okay, so my question is asking how many moles of aluminum are present in an empty soda can with a mass of 13.9. So 13.9 divided by 26.982 is equal to 0.52 moles of Al. Okay. Molar masses of compounds. For a compound, molar mass is the sum of the molar masses of all of the atoms in the formula unit of that compound. So carbon monoxide, CO, is 12.011 plus 15.999 is equal to 28.010 grams per mole. Carbon dioxide, 12.011 plus 2 times the mass of our oxygen gives us 44.009 grams per mole. Now, what is the molar mass of acetic acid? I think that the easiest thing to do here is to look at that formula. We've got HC2H3O2. We can say, well, carbon, there are 2 of them, and that has a mass of 12.011. Plus hydrogen, there are a total of 4 of them. 4 times 1.008 plus 2 times 15.999. So we add all of these up. 2 parentheses 12.011 close parentheses. 2 times 12.011 close parentheses plus parentheses 4 times 1.008 close parentheses plus parentheses 2 times 15.999 close parentheses equals a total molar mass of 60.052. So 1 mole of atoms of acetic acid molecule, or sorry, 1 mole of acetic acid molecules would have a mass of 60.052 grams. Okay. Now, converting between grams and moles of a compound. The molar mass of a compound can be used as a conversion factor between the mass of a compound and number of moles in that sample. So we could say, how many moles of NaCl are in 0.30 grams, or 0.30 grams? Well, what's our molar mass of NaCl? Our molar mass of NaCl is 22.990 plus Cl, which is 35.45 grams. Okay, so we needed to come up with the mass for NaCl, and that would be approximately 35.45 plus 22.990 equals 58.44 grams. So our question is, if we have 0.30 grams of NaCl, how many moles of NaCl do we have? Well, we know the molar mass. 1 mole of NaCl is 58.44 grams of NaCl. So now we're in a position where we simply do 0.3 divided by 58.3 divided by 58.44, and that gives us, well, it would be 0.00513 moles of NaCl. Now we can also use this information to convert from moles of a compound to moles of atoms to number of atoms. These sorts of questions can become increasingly difficult and well, not difficult, but tricky. Okay, this first one is how many atoms are in 9.30 grams of salt. This is common table salt, NaCl. So if we have 9.30 grams of NaCl, we can use the molar mass to determine, well, number of moles of NaCl. Okay, and as soon as we figure out the number of moles of NaCl, we can use that to say, well, 1 molecule or 1 formula unit of NaCl, how many atoms does it have? It has 2. So we can use that number of moles to determine number of atoms. Now let me walk you through this. 9.30 grams of NaCl, 58.44 grams of NaCl. Now that's not a number that I just made up. Instead, I remember that number from our previous example with NaCl. That's the formula mass for NaCl. If you have 1 mole of NaCl, it has a mass of 58.44 grams. So I'm going to say 1 mole of NaCl. Now, that 1 mole of NaCl has, well, it's got 6.022 times 10 to the 23rd molecules of NaCl. Okay, now 1 molecule of NaCl, that gets us down to, on that molecular level, how many, well, things are in that 1 molecule. We've got 1 sodium atom and 1 chloride atom. At this point in time, we can say that we have 2 atoms. Okay, and our goal and objective was to get 2 atoms. So we can say 9.30 grams times, I'm going to put this in parentheses, the 6.022 times 10 to the 23rd, close the parentheses, times 2. I'm going to divide that by my molar mass, 58.44 times 1 times 1. And that is going to be 1.92 times 10 to the 23rd atoms. Okay, so this was kind of a tricky question. I will be completely transparent on that. The first thing that we had to do was we had to convert into moles of NaCl. Once we converted into moles of NaCl, now we can figure out how many molecules are in 1 mole. Okay, once we had it converted down to molecules, 1 molecule of NaCl, then we could break it down further into atoms. And that's how we arrived at 1.92 times 10 to the 23rd atoms. I hope this was helpful, and we will continue rocking and rolling through the end of chapter 3.